Hello everyone. Now we'll start your next part of Unit 1, that is Introduction to Physical Layer. In this chapter, we are going to discuss about the lowest layer of OSI model called as the physical layer. The physical layer defines mathematical, electrical and timing interfaces to the network. Physical layer, major task of the physical layer is to provide the service for the data link layer. Duties of physical layers are transformation from the bit to signal, bit rate control, bit synchronization, multiplexing and circuit switching. Now we'll start from the basic concept. First is data. Data are the entities which convey the meaning or information such as temperature, pressure. Signals are electric or electromagnetic representation of data. Thus, signal is a representation of the data. The data can be of two types, analog data and digital data. Analog data is the type of data that varies continuously, smoothly with respect to the time. Voice and video are the best example of analog data. Digital data is the type of data which can take the discrete values, that is discrete in nature. The example of digital data are text and integers. Next concept is signal. Signal can be of two types, analog signal and digital signal. In analog signal, which is the signal magnitude varies smoothly in fashion without any break with respect to the time, and digital signals in which the signal magnitude has constant value or level for some period of time, then it is changes suddenly to another constant level. The example of digital signal are binary signal, hexadecimal signal. Analog signal. Analog signal can be classified into two types, simple analog signal and composite analog signal. Simple analog signal is the analog signal which cannot be decomposed into simple signals. So this is the most basic analog signal which can be used basic building block to build the other composite signal. Example of simple analog signal are the sine wave and cosine wave. Composite analog signal. A composite analog signal is made up of multiple sine and cosine wave of different amplitude added to subtracted from each other. Example of composite analog signals are square wave, triangular wave, ramp, trapezoidal signal or pulses. Next concept is digital signal. The input data, which either analog or digital, can also be represented by the digital signal. A digital signal is the discrete time signal having finite number of amplitude. For example, see the digital signal. A 0 is represented by the 0 volt and 1 by some positive voltage. Some concepts related to digital signals are bit interval, bit rate, baud rate, bit length, bit interval. The bit interval is the time corresponding to one signal bit, that is 0 or 1. Time corresponding to 0 or f1 is t, hence it is bit interval or bit length. Second is bit rate. Bit rate is also known as data rate. Bit rate is defined as number of bit transmitted or sent in 1 second. It is expressed in bit per second, BPS. The relation between bit rate and bit interval is bit rate is equal to 1 upon bit interval. Next is baud or baud rate. Baud is the unit of signaling speed or modulation rate or the rate of symbol transmission. It indicates the rate at which signal level changes over the given period of time. When binary bits are transmitted as an electrical signal with two levels, 0 and 1, the bit rate and the modulation rate, that is baud rate, are same. two level signals, the bit rate and baud rates are equal. Each level of being represented by combination of two bits, that is 00 or 01. The bit rate is therefore not equal to the baud rate in some cases. Next concept is bit length. The bit length for the digital signal is similar to the term wavelength for the analog signal. Bit length of the digital signal is defined as the distance corresponding to the one bit on the transmission medium. It is measured in the meter or centimeters. So the formula for bit length is equal to propagation speed into wave duration is equal to meters upon seconds into seconds. Next concept is transmission impairment. Transmission impairment, in any communication system, the received signal is never identical to the transmitted due to some transmission impairment. The quality of analog signal will decrease due to transmission impairment, whereas error gets introduced in the signal if the signal is digital. The most important reason for the impairments are: first is attenuation or attenuation distortion, second is delay distortion, and third is noise. Next is attenuation. The strength of the signal decrease with the increased distance traveled over the medium is known as attenuation. When any signal travels over the medium or channel, it loses some of its energy in the form of heat in the resistance offered to the signal by the medium. Attenuation is expressed as attenuation is equal to 10 log to the base 10 P out upon P in. P out is power of sending end and P out is power at the receiving end. Attenuation decides the signal strength and hence the signal to noise ratio and the quality of received signal. Second is delay distortion. The problem is particularly present in the wired medium. The distortion is caused due to the property which states the velocity of propagation of the signal through a medium varies with frequency. The velocity is maximum near the center of frequency and release as the signal frequency divides away the center frequency on the both sides of frequency spectrum. Hence, the various frequency components of signal arrives at the receiver at different instance of time, result in the phase shift between the different frequencies. This distort the signal and distortion is called as a delay distortion. Delay distortion is particularly important for the digital data. Due to delay distortion, a digital pulse transmitted over the medium tends to spread out and causing the inter-symbol inference. Next is noise. When the data travels over the transmission medium, noise gets added to it. Noise is a major limiting factor in the communication system performance. Noise can be categorized into four types. First is thermal noise, second is intermodulation noise, third is crosstalk, and fourth is impulse noise. First is thermal noise. It is due to thermal agitation of electrons. Thermal noise is present in all our electronic device and at the transmission medium. Thermal noise is proportional to the temperature and it is uniformly distributed across the frequency spectrum. So the thermal noise is called as a white noise. We cannot eliminate the thermal noise completely. So it puts a limit on the performance of the communication system. The thermal noise power is given by N is equal to kTB watts. K is equal to Boltzmann's constant, T is absolute temperature, and B is bandwidth. Second type of noise is intermodulation noise. If the signal is different frequencies are transmitted simultaneously on a common transmission medium, that is FDM, then it results into intermodulation noise. The intermodulation process frequency components at some and different frequencies of the frequencies traveling on the medium. Suppose the signal of frequencies f1 and f2 are traveling simultaneously over the same medium, then due to intermodulation process, frequency components f1 plus f2 and f1 minus f2, which are called as a intermodulation noise. Third type of noise is crosstalk. Crosstalk basically means the interference between the adjacent telephone channels. It is unwanted coupling of information from one channel to the other and adjacent channel. The guard time T is the time spacing introduced between the adjacent telephone channel represented by X1 and X2. The signal without baseband filtering has also crosstalk if the pulse tail or post cursor overlap into the next time slot of the frame. Pulse overlap can be controlled by using guard time between the pulses. The guard time is analog to the guard band between the channel in FDM system. In practice, crosstalk can be experienced while using a telephone. We can hear another conversation due to crosstalk. It can occur due to electrical coupling between nearby twisted pairs or sometimes even in the coaxial cable. Typically, the magnitude of crosstalk is almost same as the thermal noise. Last type of noise is impulse noise. All the types of noise discussed so far are reasonably predictable and their magnitude is relatively constant. So it is bit easier for the system engineer to deal with them. But the impulse noise is completely different from the other types. It is non-continuous by nature and it is made noise spikes of short duration of high amplitude. This noise pulses occur irregularly and they are extremely unpredictable. Impulse noise gets generated due to the many reasons such as external electromagnetic disturbance and lightning. Impulse noise does not affect quality of analog signal to a great extent, but it affects the digital data badly because it introduces error into digital data. It is possible to recover original data by means of sampling. Next point is performance. The performance of data communication network can be measured with the help of the following parameters. First is bandwidth, second is jitter, third is delay, fourth is throughput. So first is bandwidth. We can define two different bandwidth, signal bandwidth and channel bandwidth. Signal bandwidth is defined as the range of frequency contained in the signal, whereas bandwidth of channel is range of frequency that are passed by a channel. If the bandwidth of the input signal is larger than the channel bandwidth, the output of the channel will not contain all frequencies of input signal. If the signaling rate of input signal is increased, then the channel bandwidth has to be increased so as to pass the signal without any change in shape of signal. The maximum rate at which pulse can be transmitted through the channel is given by maximum rate is equal to 2W pulses per second, where W is equal to 1 by 2 torque. And torque is the smallest pulse width of input signal. The bandwidth is also important in deciding the channel capacity C of a transmission system. The channel capacity C of the transmission system is the maximum rate at which bits can be transferred reliably. The relation between C and the channel bandwidth is C is equal to B log to the base to 1 plus S upon N bits per second. The channel capacity should be highly possible, and to increase the C, we have the increased channel bandwidth. That means we can transmit at the maximum rate of 45.2 kilobits per second at the telephone channel. Second point is jitter. The delay introduced by the data communication network is not constant. It varies the packet by packet. The jitter measures the variability in the packet delay, and it is measured in terms of the difference of minimum delay and maximum value of delay. Jitter is defined as the variation in delay for the packet belonging to the same flow. The real-time audio and video cannot be tolerate jitter. On the other hand, the jitter does not matter if the packets are carrying any data information contained in a file. For the audio and video transmission, if the packet takes 20 milliseconds to 30 milliseconds delay to reach the destination, it does not matter, and provided that delay remains constant. The quality of sound and video will be hampered if the delay associated with different packets have different values. Next point is latency or delay. The latency or the delay is defined as the time required for entire message to reach the destination from the instant at which the first bit was sent from the source. Latency is the sum of four delay components like processing delay, queuing delay, transmission delay, and propagation delay. Processing delay: a packet consists of the header and the data field. The header contains the destination address. The time requires examining the packet header and deciding direction in which the packet is to be sent is the part of processing delay. Second is queuing delay. At the queue, the packet experiences a queuing delay when they wait to get transmitted on the link. The queuing delay depends on the number of packets arrived earlier in the queue. With no waiting packet in the queue, the queuing delay will be equal to the zero. Queuing delay can be of order of microseconds or milliseconds in practice. Third is transmission delay. The packets are transmitted on the first come first serve basis. So the particular packet can transmitted only after all earlier packets are transmitted. Transmission delay is also called as a store and forward delay. It is the time required to push or transmit all packets bits into the link. So transmission delay is equal to message size upon the bandwidth. Typically, the transmission delay is of the order of microsecond or millisecond in the practice. Last type of delay is propagation delay. The time required for the packet bits to reach from the beginning of the link to the desired router is called as a propagation delay. The signal travel at the speed which is slightly less than the light. So the propagation delay is the ratio of distance to be traveled by the signal to the speed of propagation. Practically, propagation delay are the order of few milliseconds. Propagation delay is equal to distance upon propagation speed. And the last point is throughput. The throughput is the parameter that is used to know the speed of data transmission over the network. The throughput of the system is defined as the actual rate at which information is sent over the channel. It is measured in bits per second or frames per second. Throughput is the measure of performance of any network. For the channel, certain bandwidth, a bit rate are specified. For such channel, there will be an optimum operation condition will support for the maximum net data throughput. Thank you.